Hi everyone, welcome to section 1.3, frequency tables, and levels of measurement. So the learning objectives for this section will be use rounding rules to round final answers, determine the levels of measurement for data, and use frequency tables to organize and analyze data. So first off, we're going to be talking about rounding rules for this short portion. So answers and rounding off. So these are some typical rules that we'll be using throughout this course. So one of them is carry your final answer one more decimal place and was present in the original data. We'll see what we mean in a second. And then round off only the final answer. Do not round off any intermediate results. Okay, so let's look through some examples and see what we mean. Um, so we look at this example here. Excuse me. Um, so example one, original data. Say original data is something like 2, 4, 11. Ideally they are whole numbers. Okay, so and say, when you calculate the mean, you will have 5.66. But then your final answer, you'd want to round it off to one more decimal place than the original data. And since the original data is a whole number, you would only want one more decimal place. So your final answer would be 5.7. Okay. So that's what we mean by one more decimal place. Okay. So let's look at another example. Let's maybe find some room here. Let's try another example with a different type of original data. So say your original data is something like 4.7, 3.2, and 6.3. All right, so it's in the one more decimal place. We would say something like tens place. Um, so it's in the tenth place, and so say we calculate the mean like we did for the other example. So you calculate the mean, and it's 4.733, so on and so forth. And so your final answer, the way you round this, would be something like 4.73. Okay, so it's your original data was one decimal place called the tens, and then so that means you're, oops, sorry, let me move myself out the way. So my final answer would be one more decimal place in the original data, so that'd be two decimal places. So this is also called the hundreds. Let me scoot over a bit and zoom in. That'd be the hundreds place. Okay, so maybe say the tenths down here for our first example. But that's sort of our rounding rules. You always round one more place in the original data. And then, so we'll see that a lot throughout this course. And then one thing also is that you don't want to round until the last step. Okay, you see how in these examples we didn't round until we got our final answer, and this should be the case for whenever you start rounding. Okay, but okay, so let's look at levels of measurement now. So levels of measurement, it says data can be classified into 4 levels of measurement. Okay, so the first one is the nominal scale level, and this is categories, colors, names, labels, yes or no responses, and nominal scale data are not ordered. Okay, so what some examples of these are? Examples would be gender, eye color, phone numbers, okay, things like that. You know, it can be ordered, like gender can be ordered, eye color can be ordered, phone numbers can be ordered. So it's like that's what nominal scale level categories are. Okay, so the next one is ordinal scale level. Data can be ordered, but the differences are meaningless. So what do we mean by this? So some examples of these are grades, shirt size, shoe size. Okay, so what this really means is that the data you have, it can be ordered, meaning like it can be from greatest, from best to worst, greatest to least. But you can't really find the difference. Okay, so what I mean by that is like, say you have grades, and with grades, you know, you could have a 96%, and then your friend could have a 99%. But when you look at the grade book, they're both just A's. It's better than a C or D or a B, but within that certain order, you can't find the difference. Okay, so that's what it means by differences are meaningless, right? You would both have an A in this ranking or order, but there's no really difference. You both have the same grade. So that's what an ordinal scale level is in terms of like grades. Hopefully that makes sense. But okay, so let's look at the next example is interval scale level, and that is data can be ordered, but differences are meaningful. So we'll see what that means. This is different than ordinal, where it's meaningless, but this one is meaningful. So, but in this case, data does not have a starting point. Okay, so data does not have a starting point for interval scale level. Okay, so some examples of this are years, temperature, time, and etc. Okay, so like years can be ordered. The differences in years or temperature or time is meaningful, right? Different time means different things. Different temperature means different things. Um, but the data does not have a starting point, meaning like there's no certain initial start of time or temperature or years. There's no starting point, but the differences are meaningful. Okay, so then last one is a ratio scale level. Ratio scale data is like interval scale data, but it has a starting point. So that 0 point means starting point. Um, okay, and ratios can be calculated. Okay, so some examples of these are weight, height, age, measurements, things like that. Okay, so these have starting points like, you could have zero weight, you could have zero height, you know, zero age when you're born, zero measurements, like things like that. Okay, so, and if you guys notice relating to our previous section 1.2, these, the first two, nominal and ordinal, these are qualitative data. And then the interval and ratio are qualitative data. Okay, so if you guys can notice that a bit. But okay, so that's it for levels of measurement. So now let's get started on frequency tables. Okay, so then frequency tables, um, this is just a list of what frequency table is and sort of the breakdown of them. If it's a little confusing in these paragraphs, wait till you see an example and hopefully it'll make more sense. But let me read through this and we'll see an example. Okay, so frequency table. A frequency table is a number of times a value of the data occurs. So frequency, like, how frequent, things like that. So hopefully that terminology sticks a bit. But then, okay, so relative frequency is a ratio. Maybe I should highlight these. Relative frequency is a ratio. It's a fraction or proportion, right? Meaning like decimal or percentage of the number of times the value of the data occurs in the set of all outcomes to the total number of outcomes. To find the relative frequencies, divide each frequency by the total number of students in the sample. Okay, so a lot of words, but what this really is saying is that say you have a 10 frequency, like the number of times that value of the data occurs, and then say you have total total number of you know in the sample. And so what the relative frequency is just you divide those two together, you should get 30.3 0.3030. Okay, and then this will just be 30.3% using our rounding rules. Okay, so one more decimal place. Okay, so that's like short example of relative frequency. So now let's check out cumulative frequency. Like I said before, like this paragraph might seem a little confusing, but once we do an example on the next page, then it might start to make more sense. So it's very similar to relative frequency, but this time it's accumulation, meaning like we're accumulating, we're adding things together. So let me read it through. So cumulative relative frequency is a accumulation of the previous relative frequencies. To find the cumulative relative frequencies, add all the previous relative frequencies to the frequency for the current row. Okay, so a lot going on, but once we start doing it, you'll start to see how it works. Okay, yeah, so like I said, let's go through an example and see how this frequency table works. So the question says, complete the frequency table with the following information. 20 students, let me highlight that because that's important. 20 students are asked how many hours they work per day. Their response in hours are as follows. So these are 20 responses. 5, 6, 3, 3, so on and so forth. So 20 different responses. Okay, so one thing I identify first is that 2 is the smallest hours they work per day, and 7 is the largest. Okay, so 2, smallest is 2, smallest is 2, largest is 7. Okay, so then what that means is 2 is the smallest amount of hours they work, so that's right there. And then I'm just going to count up all the way to 7. So I see a 3, I see 4s, I see 5s. Do I see 6s? Yes, I see a 6, and then I see a 7. Okay, so nothing goes past 7. So let's just have a total column here, or total row here, sorry. Okay, so now what we want to do next is count how many students each work these amount of hours. Okay, so we're gonna go through the list and see how many students work 2 hours a day. So I'm counting 1, 2, 3. Okay, so that's 3. And if you guys think you have the hang of this, go ahead and try it out. But I'll just continue to do it. So here's 3, 1, 2, 3, 4, 5. Okay, 5 students work 3 hours. 4, I'm seeing 1, 2, 3. Okay, 5, 1, 2, 3, 4, 5, 6. 6 students work 5 hours. 6 hours, I have 1, 2, 2 students work 6 hours, and 7 hours. That's our last one. Just one student works 7 hours. Okay, and then what you also want to do is check to see if your frequencies add up to the number sample. Okay, it says here 20 students are being asked. you want to make sure that this right here adds up to 20 then, which it does. So 3 plus 5 is 8, 8 plus 3 is 11, 11 plus 6 is 17, 17 plus 2 is 19, 19 plus 1 is 20. Okay, so we're good. So everything's accounted for. So now relative frequency, you know, it could be a fraction or a decimal. Okay, so then remember, relative frequency is just we're dividing our frequency by the total number in the sample. So realistically, our frequency for this one is just 3 over 20, just 0.15, and that's just 15%. Okay, so then keep going. Once again, go on if you think you have an idea. But for the 3 hours of sleep, sorry, 3 hours of work a day, it'll just be 5 divided by 20, which is just 0.25, 25%. Okay, next one is 3 over 20, which is 0.15 again, which is just 15%. Okay, so then we have 6 over 20, which is 0.30, which is just 30%. Okay, so then next one is 2 over 20, which is 0.10, which is just 10%. Okay, so then the last one is 1 over 20, which is 0.05, and that's 5%. Okay, so then we have 20 over 20 just for the sake of it, which is 1, which is 100%. Okay, so couple of things to check here is that or I'll talk about this in a second. So let's calculate relative frequency. And so like I said, that paragraph was a little might have been a little confusing, but basically all we're going to be doing is your last relative frequency plus your current frequency. Current relative. Okay, so what do I mean by that? So in this row, for 2 hours of work per day, we don't have a previous or the last relative frequency, we just have the current one. So we would just pick 0.15. Okay, so that would just be 0.15. Okay, so now for the next row, we're going to add our last relative frequency plus our current relative frequency. So our last relative frequency is 0.15. And we're going to add our current one, which is 0.25, and that adds up to 0.40. Okay, so then we're just going to keep doing the same thing. So our last cumulative relative frequency is 0.40, and our current one is 0.15. We add those together, that's 0.55. Okay, so if you're getting the idea, go ahead and jump to it. But I'll keep going. So 0.55 plus 0.30, and that's 0.85. Okay. Our next one is 0.85 plus 0.10. That's just 0.95. And then 0.95 plus 0.05, and that's just basically 1.0. Okay, so that's good. So one thing to note, is that if do not add up to 100%, like adding up to 100% here, or even like 1 It's the same thing, 1.0 here. Could be a result of rounding. Could be an issue. With your rounding. Okay, so, but as long as it is close to 100%, then it should be okay. As long as it is close. If it is close to 100%, then okay. So if it's like 99 point something, or it's like 100 point something, then it should be okay. But if you're getting like 70% or 80% or even like low 90%, then something is off. Okay, but if you're like sort of in the vicinity of 100%, then it should be okay. But so we fit out this table, so that's step one. But now we got to figure out these questions. So question one says, what percent of students work exactly 4 hours? So this is where we look at our relative frequency. So 4 hours, we know we're in this row right here. We know 3 students work 4 hours, and we found that relative frequency. So we would just say 15%. Okay, exactly 4 hours, that's just 15%. Okay, so now question two is, what percent of students work less than 3 hours? So less than 3 hours, you're not including 3 hours. Okay. So that means you're referring to 2 hours. Okay. So then if you're only referring to 2 hours, um, 3 or less, I'm sorry, like you work less than 3 hours, so everything before three, and that's just 2 hours per day, which is just 15%. Okay, so the answer is 15%. Okay, so what percent of students work from 4 to 6 hours? 4 to 6 hours, so that's this range here. So what you would do is just add up all those percentages. So you would add 15 plus 30 plus 6. Okay, and that would just be your percentage. So so 15% plus 30% plus 10%, that's 55%. So that is our answer. Okay, so now find the number of students that work from 3 to 5 hours. Same exact concept, 3 to 5 hours. It'd be 25 plus 15 plus 30. Oh, I'm sorry, I read the question wrong. So find the number of students. So that's a little different. Find the number of students. So that's our frequency. That's not our relative frequency. We just want to know the number of students. So I see that we look at our frequency column. It says 3 to 5 hours. So it'd be 5 plus 3 plus 6. Okay. So we have 5 plus 3 plus 6, and that is 14 students. Okay, so now what fraction of the students work from 6 to 7 hours? Okay, so we're looking at 6 to 7 hours. That's in this part right here. We're talking about a fraction, right? We're not talking about percentages, so we're gonna look at these fractions here. So what we would do is just add up 2 over 20 plus 1 over 20. Okay, so that would be 2 over 20 plus 1 over 20, which is 3 over 20. Okay, remember when you add fractions, you always just add the numerator when you have a common denominator. Okay, meaning the common on the bottom, you could just add the tops. Okay, so number 6, what is the frequency of students that work from 3 to 6 hours? So we're talking about frequency again, meaning like that means number of students, right? Meaning like number of students. So we're not talking about fraction or percentages again. We're just looking at the actual number of students. 3 to 6 hours. So we're just adding up these ones right here. 5 plus 3 plus 6 plus 2. Okay. So let's add those up. 5 plus 3 plus 6 plus 2, and that equals 16 students. Okay. So now number 7, what is the relative frequency of students that work 3 hours or less? So this is similar to number 2, but number 2 said what percentage of students work less than 3 hours? But this time we're saying work 3 or less. So this time we are including 3. Okay, so then we are including 3 and we're looking at the last one, it would just be 3 and less, and that's just this right here. Okay, so it would just be we're looking at relative frequency, so we can use decimals, so there's be 0.25 plus 0.15. Okay, so you would have 0.15 plus 0.25, that's just 0.40. Okay, so we added those together, but one thing you also could have done is look at the cumulative relative frequency, and it's also 0.40. Okay, and that's because it's in this weird case where it's we're just being able to add these two relative frequencies up together, and that would be our cumulative frequency from all the way up to 3. Okay, so number 8, last question, is what is the cumulative relative frequency for 4? Okay, so explain what this number tells you about the data. So cumulative relative frequency for 4, we just look at our row 4 here, and then we see our relative cumulative frequency is 0.55. Okay, so we don't have to do much there. That's just our answer. So 0.55. And so what does this tell you about the data? So what we would say is this is the relative frequency of the number of students who work 4 or less hours per day. Okay, so this is similar to number 7. We're saying 3 or less. We're looking at 4 or less for number 8. Okay, so that's what cumulative relative frequency tells us. It's that number or less in terms of the situation. But okay, so that's section 1.3. We talked about frequency tables, levels of measurement, the 4 different types, and a brief introduction to our statistical rounding method. We use this a lot in statistics, but that's 1.3. If you have any questions, reach out to me, office hours or through email, or rewatch the lecture in case you have any questions. Okay, I'll see you guys next lecture. Okay.